Hello Reshifters, this is a second video on the Redshift Jitter and I'm doing this on purpose. Let me show you how this will look if using a cloner as I did in my previous video, right? And let me put this on 105, 105 and 105. Okay, but let's take 10 by 10 by 10, which means 100. I'm not going to use this in name and instance mode. I'm going to use it in render instance. And you can see the default is instance, right? Which means if I put something in here and add a jitter node, everything works just fine, right? Until you change the cloner to render instance, which of course breaks everything. Multi-instance, the same thing. Although they're tiny different colors, something is clearly different. First, I'm gonna explain what's going on internally, okay? If I convert this cloner right now using the C key, which is make editable or current state to object, whatever, C, so make editable, bam, you get 100 different meshes, each with a different name. And that Redshift can use because the name ID here, it's these, and these are unique, okay? Now, here's what's happened if I'm trying to do the same thing with render instance. Okay, I'm gonna get one mesh and everything else is an instance, which means internally the name of the mesh of the instances is the same as the name of the mesh, so there's no variation. Okay, and the same thing happens for the multi-instance, a bit different because you get one mesh, one instance, and this instance is actually a point cloud for the rest of the meshes or instances. Okay, so the question is, how do we make this work, especially with render instance? And this is clearly visible when you're trying to use a matrix scatter. This is way more complicated with the matrix scatter because, well, matrix scatter is an instance per se. Okay, and I'm gonna do the same thing here, 105, 105, and 105. Right, this doesn't matter because this will be 10 and 10. Okay, still 100. Well, you can go to huge numbers using this. Now I'm using grid here, but I could have used, for instance, let's take a plane, right, and make it bigger and say, hey, the matrix should be using the object, which is the grid or the plane and whatever. I don't want to see this visible. I'm just using it to scatter things and no alignment. And so these are like that, right? I can say, hey, I want 100 or 10,000 different instances, right? And this is super fast, super efficient. So it's the way to go. Now, still gonna use 100, right? And the thing is, this is not giving me, the jitter node doesn't give me any variation. Name ID doesn't work at all for me because it's just one mesh, right? Everything else is ID, but I can go to object ID maybe. Do I get something? No. Or user data ID. Everything is still the same, but the user data is editable, which means, hey, these are changing. So here's the approach. If I can get some user data that differs every single instance, then this will work, right? So maybe the easiest way for a non-technical guy would be to come here and add an effector, a random effector with no position, rotation, or scale, but which can change the effector color. And you can see each one is different, right? But I have somehow to retrieve this color and use it inside the shader. So color user data, and this will use the MoGraph color. And this will give me this. which I can pipe into the general user data and hope for the best. Nothing happens, right? Because this is too small. What the jitter expects is an integer number for each, or a float number for each user data per object. So we have like 100 there, right? And we get our thing. And you can see here that the hue seed, it should work somehow. You don't see it much, right? Because this is 0 and 1. But if I put this something like this, right, then I probably can use this. You see, this works. Doesn't have much variation though. I mean, the color varies, but some of these are kind of the same. I mean, you get a big change where the color is it's strong, but you don't get much change where things are not that big, right? I mean, if you're looking at the color user data here, it looks to me that these, which are some kind of black or whatever, get more than anything else, right? And things that are like really kind of color get less, right? I mean, you go here and then you change this. For some reason, this guy doesn't change much. You would expect that to happen, right? It doesn't. So, okay, well, this is a way to make this work, and you can multiply this by 1,000, right? Still gives you some, but not as you would expect, right? Now, at this point, this is a bit, it looks like limited, right? Not so funny. Here's the problem. The color user data that you have here is not much. So what I can do is try to do a bit of math, okay? And you have to understand one little thing. This, when it gets into a multiply node, this becomes a scalar. Okay, so because this accepts a scalar or integer, so basically it's float anyway. And here's the thing, this is an add node, right? And you will see that it starts to vary things a bit more than before, right? It doesn't do much around here because there's nothing, but it gives you some more randomization, okay? And at this point, yeah, you can say, hey, I can use that, and let me put a dome light because I want to see where the holes are, and there you go. So you have a multiplier here for the number of colors, right? And, or let's say 100. And then you can use the second this guy color offset to multiply, or actually not multiply, move the values around, okay? It's a nifty way to do things. Now, the best part with the scatter object is that, well, magic scatter object, is that you can have a lot of these. I mean, I have 100. I can have a lot more. And believe me, it's a lot more. In this case, it's what? Let's see, 1, 2, 3. It's 1,000,000. Okay, and I can make this small, 10 by 10, and this should still be fast. Okay, I do have 1,000,000 of these. And let's try 1 and 1. There you go. Okay, well, maybe 2 and 2 will be a bit more easy to read. And this will still be fast. Look at that. Okay, and the same thing with the jitter node, and we're gonna try to use this. Gives you some values. So the variations are pretty quick and really easy to use because the matrix scatter uses less memory than a cloner, right? Because it uses just instances. and you can use, as I said, millions of them. Okay, I think you can get to 10 million easily. Okay, and I don't think Redshift will have a problem with that. It takes a bit to update, well, to create the point cloud, but after that it should be okay. Takes a bit of updating object. This is happening on the export side. Okay, but when this is starting to render, preparing scene, it should be fast. Let's wait a bit. Okay. Come on. It's 10 million though, right? And you can still work in your scene with 10 million instances. And I can still come here and change this. It should happen quite quickly. But with 10 million, you might have to wait a bit. Not much, as you can see here, right? It still changes, but 10 million, it's a bit slower than 1 million, but still, it's working just fine. Okay, it's pretty fast. Come on, guys, I have 10 million instances here, and each one is different, right? So that would be one way. Now, there are other ways, maybe more complex, to do the same thing. This is probably the simplest thing because it uses the random effector to create a random color, right? Let's try without it. And you know what? I'm not gonna wait for 10 millions of this. 1,000, it's okay for me. Maybe these are too small now. 2020. Okay, let's try 50-50. Perfect. Okay, and let me just turn off the background for this. At this point, I have no variation because the color user data, well, in this case, nothing injects color into the matrix, right? But I could use something else. Scalar user data gives us something called object ID normalized. And this is to something from 0 to 1, and each instance, it has a slightly different color, right? We can use that instead. And the process is the same. I mean, move some things around here, and then change some things around here. And you can see these are kind of staying the same when I don't use this. So you have to use both an add and a mold. As I said, things can get a bit more complicated if you're starting to get into creating random numbers using OSL. Okay, but simply as this, without doing much, just using a mod, an add and a mul, right? Add, addition, and multiplication for the jitter using user data, it's probably more than enough. Okay, you can vary things easily. Now, probably you can try to do something like, I don't know, if you're trying to do foliage, right? You might want to do something like this. And let's say these are the leaves of let's say this is a multiplier for some leaves. Okay, and because the leaves are already colored, you're gonna get or we're gonna get something like this. Just you want to vary a bit of variation, and maybe the hue a bit, right? But you can see here, even if I'm moving the hue around here, I'm not generating much, right? So you could, for instance, create two of these and then use something like this to differentiate, or like a color uh, switch. Okay, so you're gonna go for a switch, a shader switch, and you have two different colors or three different colors or type of colors of leaves colors, right? Let's say this is one, this is the second one, something like this. It's a dark, and this is more well, here comes the the atom, right? And it's thinking about, okay, I'm gonna put this one here. I need an int, not a shader switch, and I need to make sure that this guy goes into the 0 to 3 range. So we're gonna go here to int. Well, okay, actually 0 to 2 because it's just three of them, and there you go. You have some that are some color, some are another color, and so on and so forth, right? And you can have control over this. It's a bit easier than using the color jitter, right? Because in the end, we're just moving data around, and you can have a, let's say, a palette of colors that you want to do that, right? Now, if you want a lot more variation, because there's no point in trying to use nested of these nested shader switches, you can go back to jitter and use the color and then play with this until you are happy with them, right? And let's make this, I don't know, you can split this as an with the color splitter to get the hue, saturation, and value, and have different jitters for each one, and then make this really, really complex. But you can see it's really flexible, and the nice part is that the scalar user data you can have here using geometry ID normalized can act as kind of a seed or user data node for the jitter, and this can give you actually instance mode or two instance for a scatter or a cloner in render instance mode. Hope it helps. Have a great day. Cheers.